Code essentially, when you explain it to people, okay, so what do you mean by code? Well, code is literally just a language that you have to describe your ideas in for the computer to be able to execute them. And the computer is a very stupid machine in many ways because it needs to have everything very clearly described. So in that sense, it's a language or a way of describing logic. And then you add different kind of parameters or different logics to it. Maybe you add interfaces, etc. So the code can become very alive later. But in its basic form, it's like lines and lines of text, and it doesn't look very friendly or very human or very elegant at all. And sometimes code is very, very frustrating. But it also is. There is a certain elegance to being that precise.
When you write a computer program, you are basically encoding an idea into a specific notation that a computer can run. And those ideas, which oftentimes in software we call algorithms, one of the core ideas of processing is this idea of sketching with code. And so actually the files that you save in processing are called sketches. And the idea there is that instead of just imagining something, you can actually write a small piece of code and then experience it and then develop it from there. So for everything that I do, and that many people who work with processing do, is to make a lot of sketches by hand first as a way of like really quickly getting ideas and imagining what things can do. But then at some point you move over to this idea of sketching in code, where you make small samples, small tests, small prototypes, and then you launch the program and sort of see how it's working. And then from there you make changes and modifications, and it's called like an iterative design approach or iterative methodology, where you gradually you see it and evaluate it and then make changes from there.
That's in real contrast to the way that you typically think about writing computer programs, where it's this very methodical, like, well, I'll solve all the problems first in my head, and then I'll sit down and make the code that does that and just debug it. We want people to do is try something, write a little bit of code, see what happens, write a little bit more code and see what happens, and not feel quite so precious about the things that they make with code, and to be, have that same sort of comfort of when you're dealing with your sketchbook, being willing to flip to a new page or scribble something out or crumple it up and throw it away and never look at it again. And
one of the most important advantages of processing is that it makes it really easy to teach programming to people that are primarily interested in visual design and the arts. Processing makes it a lot simpler to write programs that put things on the screen faster.
The process of learning processing usually involved drawing a line on the screen. That was the first step. Draw a line from point A to point B. And so right away you've got you're looking at a simple but a piece of art that you've made.
You learn to program computers by drawing. You learn to program computers by loading in images and doing things with those. You learn to program by making animation and interaction, visual experiences. So it's a way of basically bringing what we think is really thrilling and exciting about software into the visual arts at a level where people who are visually motivated and focused can explore, experiment, and play with code as a new way of realizing ideas.
And in particular, people who think visually, designers or artists or people who are used to thinking in terms of images or in terms of structure or form or aesthetics, they suddenly can work with processing, and processing already is oriented towards that kind of work. And it's more about supporting their activities as creatives than it is about having a perfect code, if you will. So compared to other programming languages, processing is much more directly prepared for people who might not be the greatest technicians, but who have good creative ideas.